Your homework. So here's the homework for chapter 4, the first couple sections. Right. Cool. Gotta put it back here. Man, it's loaded back here, man. Let's see. Here we go. Alright. This one here. Yeah. Put it over here. It's just like the math side. Alright. Alright. Alright guys, so let me start with the true basics. We are getting into fractions, which scares even my math 281 students. It's crazy. Well, not scares them, they just have some trouble with it. Alright.
Just one.
Yeah, so if you cut this circle into 4 parts, what fraction of that circle is? Say it is 1/4. 1 part out of 4 total parts. Let me stop there for a second. I like it. I like it. Now that pretty much people get this idea. What if I had this ice cube tray? And there were
3 out of 8.
so how many? So these are ice cubes. So what percentage or what fraction? Let's not go to a percentage. What fraction of the ice cube tray has ice cubes in it? 3 out of? Yeah, 1, 2, 3 out of 8. Alright, let that sink in. Now, let me say this real quick. If you have no trouble with what I'm doing right now, just stay quiet and do your favorite, look at your favorite part of the ceiling, whatever. I love it. Alright. If this doesn't make much sense, if I fill this thing up, there's 8 spots, right? 8 spots. So, however many, it's going to be out of 8. And if I have ice cubes in every spot, well then that's what out of 8? That's 8 out of 8, which means 1 whole tray is full. That's all. So fractions give me an idea of how close I am to being a whole number. They fill in all the blanks. If I just go 1, 2, 3, we know that in between 1 and 2, there's actually an infinite number of numbers. And we start doing fractions to fill that in a little bit. Cool. So, let me see. I'm doing more ice cubes. I need one more. You can do it, Jeff. So what if I had, what would that be? 4 out of 8. Now, exactly. If I took that ice cube and I plopped it over there, now visually it makes sense why you can write this fraction a different way. Because I wouldn't say 4 out of 8 spots are full. I could just say how much of the whole tray is full. 1/2 of the whole tray is full. So if I divide this by 4 and divide this by 4, I get 1/2. So physically, there's an interpretation of a reduced fraction. Is that
like breaking it down to the simplest terms?
Yeah, exactly. Right? If, let's see, it's good. So I like this example because it's a nice visual of what 1/2 means. This is definitely 4 spots out of 8 that are full. But 1/2 of the total thing is full. That's another physical way to look at it. So that's why that fraction is the same as that fraction. They both represent the same physical situation. And if you did this on your calculator, 4 divided by 8 or 1 divided by 2, you get 0.5 either freaking way there. Math doesn't care which one you use. Yeah, like it, maybe.
Which one do you want us to use?
Always, unless it says otherwise, you always give lowest terms as an answer. All right? So if you give me 3 over 9 as an answer, maybe it's the right number, but it's not the right form. It's got to be reduced.
Thank you.
Sure. Yes, sir.
What's 0 equal to 5?
So if you try on your calculator, do 4 divided by 8. Try it. Or do 1 divided by 2. Try it. Nobody's trying it, so I guess everybody believes it. But either one you do, you will get 0.5. Now I know we're not to decimals yet, but we should know that 1/2 is 0.5. Right? 2 of those make a whole. What's 0.5 plus 0.5? 1 whole. I like it. All right, how are we doing so far?
Good.
Good. I like it. So there are several problems. In fact, let me pull up the book so you can see what the book's problems look like. That look a lot like this. What's up? You want it back? Fold it behind your head. Fold it. Put it back. Like that. Is that better? All right. You have full range of sight now. I like that.
Yeah, I was looking like,
All right, guys. I love these ice cream trays for some reason. All right. So what's this total situation? How many ice cream trays are full? You got
1.
1 and
3 out of 8.
3/8. Now stay with me now.
that's all.
This is kind of neat. Now again, I got to remind you guys every now and again. I know some of you guys got fractions down. Great. That's awesome. Enjoy it. Just stay quiet for those of us that don't, right? Maybe this will work. Maybe you were too optimistic, Jeff. Hey, all right. So now watch this. This is kind of neat. Let this be neat. What's a kind of a silly way to represent? That's 1 and 3/8. There's no question about it. That's 1 and 3/8. It's 1 full tray and 3/8 of another tray. So overall, I got 1 and 3/8. It's sort of like saying you got 1 and 3/8 gallons of gas in your car. That's a place that we use fractions to describe some amount. What's another way to write this? It might be kind of silly. We wrote it that way earlier. Out of 8, how many? 8 eighths. And this is how many? 3/8. Now what's 8 somethings plus 3 somethings?
11, 16. What?
I know where you're going. Now watch. What's 8x plus 3x? What's 8x plus 3x? 11x. Is that cool? 8 chairs plus 3 chairs. 11 chairs. Not 11 double chairs, right? 11 freaking chairs. 8 pineapples plus 3 pineapples is 11 pineapples. 8 eighths plus 3 eighths is 11 eighths. Period. Is this more than 1? Yes. In fact, how much more than 1 is it? 3. There's a whole one and 3 more beyond it. 1 and 3/8 is the same thing as 11/8. We'll get more into mixed numbers and how to represent them in more than one way. But for the first section, they really just want you to know how to write like a full thing plus extra. So here, while I plug this in, you guys try this one. Don't say anything out loud. That looks kind of good. So this whole thing, what do I mean by this? Hopefully you understand. How much of that circle is shaded? Yeah, this whole thing. Careful now. Oh, okay, sure, but that's one. So 2 whole circles.
2 and 3/4.
And 3/4 of a circle. I like it. So that represents 2 and 3/4. I like it. Sweet. And just to kind of, again, piggyback on what somebody was just saying, this is 4/4, right? If you kind of think about it like that, is that cool? This would also be 4/4, and this is, so how many fourths do I have total? Yeah, 4 and 4 is 8 plus 3. I got 11 fourths total. It's just like 4 chairs plus 4 chairs plus 3 chairs is 11 chairs. The chairs don't become chairs cubed, cubic chairs. All right, how do you sit on this thing? I don't know what that would look like. Yes?
So if you give us a problem like the equation, I guess would you write it this way or the one in the bar?
Oh, I would be specific the way I want you to give it to me. To begin with, it'll be mixed numbers, but I figure since we're talking about mixed numbers and we have this visual representation, I wanted to show you this a little bit early. You got what's called mixed numbers, and you have, anybody know what this one's called? Improper fraction. This is proper and this is improper. This is mixed number. Why do we call it mixed number? Because it's got a whole part, a fractional part. So it's a mixture of whole and fraction. This is an improper fraction because a true fraction is less than 1. So when I say there's a fraction of the cost, it better be some number less than 1 times the cost. It should be less than that, right? So this is what we call an improper fraction.
You're going to have something like that on the test, huh?
Oh yeah. Oh yeah. It's in your future. So let me pull this up. Let me show you guys what's happening. Alright. So again, you get on my webpage, go to People, Jeff-Waller.
You pulling up the book right now?
Yeah, I got part 4 up here now. Just to show you what some of this homework looks like. I know some of you guys got the, what do you call it, the copies, but some of you guys didn't. They love pizza with this, and I'm like, yeah, but fraction problems with pizza. So this kind of problem here, you're going to see this kind of thing. Look at 2a.
That's the homework, right?
Yeah.
Yeah. Wow.
2a, this problem right here. What fraction would that be?
7 out of 12.
And how many slices are there? 12. Out of 12 slices, how many are shaded? 7. So it will be 7 over 12. So the fraction 7/12 means exactly that. 7 out of 12 things are shaded, or 7 out of 12 people get something, or 7 out of 12, whatever. I like it. How we doing? All right. Let's see what other kind of weird homework they got for us.
How do you represent 7/6?
Oh, how would you represent 7/6? That is improper.
Right.
So what is 7/6? It's the whole thing plus how much extra? The whole thing would be what over 6?
1 and 1 over 6.
Yeah, if I had something in 6 parts, and the whole thing, so 7/6, a whole thing would be 6/6. Well, how much extra 6 is there here?
1 slice.
So it would have to be another thing, cut into 6. Can you do it, Jeff? We'll find out. Yeah, I can do it. With 1 extra piece, right? Whenever the top is bigger than the bottom, that's a whole plus a little extra. And you can kind of see that. Isn't this equal to 6 plus 1 over 6? Oh, shit.
So would it be wrong if you would have put...
You guys with me? 7 is 6 plus 1. Isn't that 6 over 6 plus 1 over 6, which is 1 and 1/6? And again, that's a little bit going into the future a bit, but Don't freak out. Like I just said, that's a little bit in our future. Yes.
So the diagram, it would be wrong to have the slice by itself and not with the whole circle? Like the extra part?
Once you sort of visually you need that idea that there are 6 total parts here and only one of them.
What I'm saying is it wrong to put it without that, in your eyes?
It's not wrong.
Okay.
But to be clear, you should. To make sure that I understand what you mean. Do you see what I'm saying?
Specific, yeah.
In general, it wouldn't be wrong. You could have an ice cube tray full, right? Full, and then one little cube.
Yeah, that's what I'm getting at.
But
With the cube, you get the idea of what I'm trying to add.
if I have this, then I'm certain that I see what you mean.
Yeah.
Do you see what I'm saying? Yeah. Okay.
I mean, no room
This
for
means 1 1/8. But still, to be sure that I know what you mean, you want to show. Yeah.
Yeah, that's what I'm
Okay.
getting at.
Makes it easier to correct.
All right.
Oh, okay. Oh, that's funny.
See why I asked?
For those, do you actually have to show like all that work, like the fraction part?
Oh no. That's just me going crazy, showing a little extra. Because this is 1 1/6.
Yeah.
So 7/6 must equal 1 1/6 somehow, and this is the math that connects them. It's not like a guessing game. There's actually math you could do to see that is that.
Yeah.
And some of you guys might know you divide 6 into 7, but here's a beautiful way to sidestep division a little bit.
I didn't even think about doing that.
I know, it's crazy. And a lot of people don't see this, but I think this is beautiful. Because it really highlights where that 1 comes from. If only 7 was 6, well, how much above 6 is it? 1? Oh, that's this extra stupid 1. So it's extra. Okay, maybe. So this question, number 13, is the question you just asked me, Dan.
Yeah.
See, number 13 says 7/6 represent that using circles. So that's what we just did there. So you guys try number 14. Try to draw circles that would represent 4/3. 4/3. Number 14 up there. 4/3. So show me the slices. I'm going to have to go get some pizza after this. Making you hungry?
Fine.
Aw. I remember, college student, I ate a lot of ramen noodles.
That's true.
Ramen noodles and cheesy poops, man. The lunch of champions. Cheesy poops. No college students, my cheesy poops. So, 4/3. A whole circle would be how many thirds? 3/3. So how many extra thirds? So I can represent this as a whole circle filled in, plus how much extra is there? 1/3. So what do I need to represent that?
Another circle.
Another circle
Cut it in 3. Say 1.
and 1 filled in. Right? So that would be 1 whole and a third, which is 3/3 plus 1/3, which is 4/3. All right, let me stop there for a second. Do you guys see how to see the extra amount?
Mm-hmm.
So let's just focus on that for a second. So if I had 11/7, how much extra is there? 4. All right. Do you guys see that? Because 7/7 would be a whole, then I would need another one 4/7 to make 11/7 altogether. All right, here's a little trickier one. What you got, Jeff? I don't know, Jeff, I wasn't right. Oh, 11/5. What's the extra?
1.
1.
Yeah,
5 goes into 10. So there's only 1 extra. So the way you think about the extra is not just subtract these, but in general, how much above, let me see how I can say it. How much above a multiple of this is this? So 5 times 2 is 10, that's 1 above it, so there's 1 extra. Another way to think about it is, what number can 5 go into that's below 11? 10. So the extra must be 1, because it's not 10, it's 11.
Almost like division.
Well, it is, but it's kind of like expanding the idea of division a little bit. If it was 10/5, that would be
2.
2. That's crazy. 11 over 5 is 10 plus 1 over 5. Stay with me.
That's 2 and 1/5.
And what's 10 divided by 5? 2. And what's 1 divided by 5? I don't know. 2 and 1/5. So 10 over 5 is a full 2. So 11 over 5 must be a little bit more than that. Does that make sense? And the little bit more is exactly the amount that's extra. There's an extra 1/5 in there. So let me take a step back. If I had 1/5 of a tank of gas, and I got, so my car, here's my car. It actually looks, yeah, I got my Jeff Bulletproof Glass Pope Edition car. Pope Edition. And I've got a little container that actually holds 1/5 of a gallon of gas. All right. So I got 1/5 in there. How many of these little containers would it take before I'm filled all the way up? So what I mean is, if I had one of these containers in, now where am I? 2/5. Do you understand why somebody would do this?
Yeah.
Because their brain goes 5 and 5 is 10. But what's the actual reality? One of these plus one of these is 2 of these. Right? The bottom doesn't change. The top is keeping track of how many of the bottoms you got. Okay, maybe. Yes, sir.
What did you add another 1 over 4?
Well, this is me. So if I put one more, this is a neat example. Let's say I've got 1/5 of a gallon in my car. I've got a little bucket that can hold 1/5 of a gallon. So I go over there, fill it up, come over there, and then you see what I'm saying? I have no idea why. I'm in the Walking Dead time. I'm siphoning it out of this car and then put it over there. All right. So if I do that once, I'm at 2/5. To do it another time, I'm at 3/5,
4/5.
4/5, 5/5. So 1, 2, 3, 4 times, right? I need 4/5 more to make a full tank of gas,
Does
right?
the bottom ever change? It never.
Say again?
Does the bottom ever change?
So what's going to happen is, now watch. I love the question. You ready? The answer is it's got to change at some point. So can I do this 3 11s plus 2 11s? What would that be? 5 11s. Beautiful. Not 5 out of 22. I'm like, I don't have any over 22s. How do you get 5 of them? What do you have 5 of? 5 11s. So it is just like 3x plus 2x. 3 of these plus 2 of these is 5 of these. That doesn't change. Now, what if I had 3 11s plus, what you got, Jeff? You got 2 over 22.
Wow. That's 1/11 each, right? No.
You multiply the bottom one by.
I don't know what I'm talking about.
You ready? So this one we actually kind of know. Can't I divide this one by the same number? I can divide this by 2 and divide this by 2. So this is now 3 11s plus 1 11s. And then you can put them together. So the whole idea is, if the bottoms aren't the same and I'm trying to add or subtract them, then I'm going to have to figure out, how do I make the bottoms the same? Now that's in our future. We're not quite to LCD yet. And some of you guys are like, yeah, let's not go there. But we are going to go there because it's hugely important. Because not every fraction is going to be already with the same denominator, sitting there waiting for me to come along and do math to it. That's not the way it works. Alright, maybe. So just to allay some fears, there are some things I'm doing today that's a little bit beyond section 4.1. Because it leads, and I got questions, and it leads to other things. Let's look at what they got here some more. So mostly this 4.1 is going to be concerned about these models. How to model fractions, right? Like this one right here, this problem right here. Sorry, let me zoom in on it. Oh, there it is. What kind of fraction would you use to model number 19 here, this one?
Proper.
Mixed.
Yeah, either improper or mixed, I like it. So as a mixed number, what would it be? 1 and 2/9. Kick ass. Does everybody see that?
Yes.
Cool. So it'd be 1 and 2/9. Or it's how many ninths here?
11 over 9.
9 ninths. Is that cool? 9 out of 9 plus 2 over 9 is 11 over 9. Because how much extra is there on top? 2. Where do you see that visually? There. There's 2 extra, so it's not 9 over 9, it's 11 over 9, because there's 2 beyond a full. Okay, maybe. How are we doing? I see some concerned looks. Let's see what the instructions say here exactly. Oh, here we go. Oh, they do have this. Alright. Alright. So it's a little bit more immediate than I thought. So they do have some of this rewriting of mixed numbers as improper fractions. So let me show you the shortcut for doing this. Some of you guys already know the shortcut. I've shown you a way to do it that I don't think people see too often. So what am I talking about? I'm talking about this. If I'm given a mixed number, how do I convert it back to an improper, or if I'm given an improper fraction, how do I make it into a mixed number? So it's mixed number to improper fraction. And vice versa. Improper. I like that. Go to Target, look at the improper fraction. Alright. So does everybody know the shortcut? And then we'll try to figure out why it works. To go from mixed number to improper. So if I had like 2 3/5. Yes, ma'am.
Don't you multiply 5 and 2 and then
I love it. Do you know why you do that? You're like, oh man, come on, you didn't tell me there's a second part to your question.
I just know it works.
Just know it works. Why would you agree that it works? Why would you say it works? I would say, why the hell does that work?
Because when you...
Say again?
Matthew grammar.
No, 'cause
Math grammar? I like it.
when you
The
reduce,
grammar
you
of
divide.
math.
I don't know.
Say again?
Because when you reduce, you divide.
You ready?
So you're doing the opposite.
You ready?
I don't know.
Oh, the slightly evil thing about this, okay, is this cool? You guys understand this does not mean times, right? You've already been writing it earlier what this really means, and that's a horrible idea they had to represent it like this, because we think that something next to something is times, but this really means 2. No. What does this mean? 2 plus 3/5, right? 2 and 3/5. All right, let me stop there for a second. This is number one that you have to understand what that means. Now listen. I'm going to show you why the shortcut works, and then you just use the shortcut. But I'm not going to just have you do a shortcut and you don't know why the hell it works. That ain't how I operate. It should be the way you don't operate either. You should be like, wait, why does that work? If the teacher can't answer it, go, I need another teacher. Go get somebody else. If they only know shortcuts, they ain't no math teacher. There's something else.
5 times 2 plus 3.
Alright, so this is going to go a little bit beyond where we currently are, but I want to see if you guys can go there with me. So first off, this is 2 over 1, right? Anything can be put over 1, and it's like, oh, it's the same thing, amazing. Alright, so let me write this again. 2 over 1. Now, can I add those together?
No.
The way it is? No, why?
Different.
Yes, okay, gotcha. Y'all came strong at the end of it. Alright, now, to explain how to do this requires something we haven't gotten to yet, but this is an easy example of this, so I'm hoping you guys are going to be with me. How do I make this a 5? Because this needs to be a 5 to be able to add with his other fifths, right? So, yeah, multiply by 5. Whatever do to the bottom, I have to do the top also to keep it the same fraction, right? Because watch, if I do this, if I multiply by 5, what is 5 divided by 5? 1. So I just multiply by 1. That's what makes it legal. If I do the same thing to the top and the bottom, I'm actually just multiplying by 1. I can multiply anything in the universe by 1. It's always allowed. Anything. Give me something. I'll multiply by 1.
Times pig.
Pig! Hey, I'm done. All right. You guys Now most of you guys should know this is how you do LCD, and this is a relatively easy because 1 can become whatever the hell you need it to be. So this will be 10 fifths plus 3 fifths is 13 fifths. Now, I'm not saying you have to do it this way from now on. This whole thing is explaining the shortcut I'm going to do that you can use. But you have to at least see once why the shortcut works. So what did we do here? We did 2 times 5, because this needed to become a 5. So look, here's the shortcut. 5 times 2
10
plus 3, 13 fifths. But this is why the shortcut works, because whatever that bottom is, I'm going to multiply this by it, because that's what it has to become. So another example. So that's why it works, but now we can just do this. If I had 3 and 4/7, how do I make that into an improper fraction? Yeah, 21 plus 4 over 7. 25/7. So totally, please, dear God. I hate it when somebody comes back and says, "You said we had to do it." No, I never said you had to do this shit. This is why that works. Now do that. But at least now know why it works. How are we doing? Is that cool?
Yeah, we gotta show it like that.
So when you
No, yeah, you can even just go